Hello everyone, and welcome to Math Analysis Chapter 12.1. My name is Marcus Chua, and today I'm going to be talking about sequences. First, a quick explanation about what sequences are. By definition, a sequence is an unending succession of numbers. A sequence can also be defined as a function whose domain is the set of positive integers. Terms can be defined as the numbers in a sequence. Shown below are two graphs. The graph on the left is a function where the domain is all numbers that are greater than 0. The graph on the right has a similar shape, but it can be identified as a sequence because its domain is the set of positive integers. When we write out sequences, we have a few options that we can use in terms of notation. The first is called brace notation. Brace notation can be used when the formula for the nth term of a sequence, which is sometimes called the general term, is known. Brace notation works by writing the entire sequence within a set of brackets to indicate that it is the formula for the nth term. The second method of notation is called recursive notation. This method works by assigning a value to the first or the first few terms of the sequence and defining the nth term of the sequence by utilizing one or more of the terms preceding it. The third method of notation is called summation notation. Summation notation is a more efficient way to express the sum of terms in a sequence. Summation notation utilizes the Greek symbol sigma as an indication to sum up the terms. The letter K in summation notation is called the index and indicates which terms to start and end the sequence with. Shown here are a few properties of sequences that are very useful for performing functions with summation notation. Property number 1 shows how you can isolate C using the distributive property. Properties number 2 and 3 use the commutative and associative properties to expand a sequence in summation notation. Property number 4 is very useful to use when we have a sequence in summation notation where the index begins at a number that is greater than 1. Next, we also have a few formulas for summation notation. These are incredibly useful for scenarios where the expression contains either a constant or a variable to a certain power. Now, let's look at a few examples to practice what we've learned. In example 1, we are told to write the first 6 terms of the following sequence. Here, we notice that we are looking at a piecewise defined function in brace notation. We can solve this problem by plugging in numbers 1 through 6 into the function. If we plug in 1 into this equation, we will notice that 1 is odd, so we can calculate C of 1 as 1 over 1, which equals 1. If we plug in 2 into this equation, we'll notice that 2 is even, so we are given C of 2 is just 2. If we plug in 3 into this equation, we'll notice that 3 is odd, so we can calculate C of 3 as 1 over 3. And we can continue using this function for terms 4, 5, and 6. In example 2, we are told to find the first 5 terms of this recursively defined sequence. We are given u sub 1 and u sub 2, so we can immediately indicate those for the first 2 terms. For the third term, u sub 3, we can plug in u sub 1 and u sub 2 into the function. Using this sequence, we can see that u sub 3 minus 2 would just be u sub 1, which is 1. U sub 3 minus 1 would just be u sub 2, which is 1. Therefore, we get 1 plus 1, which equals 2. This pattern continues for the other 2 terms. For the fourth term, we essentially add u sub 2 and u sub 3 to get 1 plus 2, which is 3. For the fifth term, we can add u sub 3 and u sub 4 to get 2 plus 3, which is 5. Finally, we have example 3, where we are told to find the sum of a sequence in summation notation. For this problem, we will be utilizing our properties and formulas for summation notation. To begin, we will use property number 2 to expand the sequence. Then we can use formulas number 5 and 8 to calculate the sums. given that we have expressions that contain a constant and a variable to the power of 3. Finally, we can calculate and sum up the numerical values. As this lesson comes to an end, I would like to note that much of the material shown in this video was thanks to Michael Sullivan's Pre-Calculus Enhanced with Graphing Utilities 6th edition. This concludes Math Analysis Chapter 12.1, Sequences. I hope you found this helpful, and thank you very much for listening.